Alright, so how do we calculate the common difference D of an arithmetic sequence when we're given two terms, okay, and their values? Now this relates to our knowledge of formula for D. But before that, let's just consider this example. Okay, let's say we have 5 terms: T1, T2, T3, T4, T5. We use poles to represent that. Okay. Now we call the distance between each D, and each distance is the same. Now if I just consider term 2 and term 5, we know that from term 2 to term 5, okay, if we take the difference, from term 2 to term 5, T5 minus T2 is equal to, we can see there are D plus D plus D, there are 3 differences. Okay? There's 3 differences between them. So, we can calculate the difference by dividing over by 3. Okay? Now we can see that 3 is equal to 5 minus 2. Let's say we consider from term 1 to term 4. Now based on formula Tn equals T1 plus n minus 1d, T4 is going to be T1 plus 4 minus 1d. Okay? Now what that tells us is, if we rearrange this, T4 minus T1, the difference between term 4 and term 1 is equals to 4 minus 1d, which is 3d. So between term 4 and term 1, there are 3 d's. Okay, a difference of 3. And then rearrange d, we have d equals T4 minus T1, 4 minus 1. So we see a pattern here. We see there common difference D is equal to your 2 terms, the difference of 2 terms, divided by the difference of the n. Okay? So, we can write this as a general formula. Let's say D equals, given term n and the value, then D must be equals to Tn minus Tn over n minus n. Let's apply this into this equation, or this problem we have. So we're given T4 equals 20, T10 equals 62. We have to calculate what is D. So, substitute into this equation, D equals, now it's best we use the bigger term, okay? T10 minus Tn, because it's easier to work with. And then 62. No, sorry, we got m, which is 10, minus n, which is 4. T10 is 62, minus T4 is 20, divided by 10 minus 4, which is 62 minus 20 is going to be 42, divided by 6, which is 7. So that means each of these difference is 7. Okay?